Hello there. I started doing this tutorial and I got sidetracked, believe it or not. And hopefully we'll do it again. What I wanted to talk about now, this moving to back to the C++ stuff, is something that I don't know if it has a name, if there's a name for it. I don't know if anybody's ever talked about it. I don't recall reading about it. It's a kind of member of a class that has the property that it is restrict that the class has only restricted access to that member, whereas other types of objects would have access to that data. Could be data or code, I suppose. So, in a sense, I'm talking about something that's a member of a class that's private, but not private for the class's use, but private for the use of some external entity or object or collection of objects. Now that came up in the context of that little XML thing where I added that list. And okay, now in this case it was, I wanted to make use of this idea to control access to that particular list, and specifically from the class that it had to be a member of. Let me pause for a second and I'll try and draw a picture. Okay, took a little while. This is a scenario which has come up in my case because of a poor design decision, but this could come up where you haven't made a poor design decision and you simply want to implement something like this because this would be the safest way of handling a collection sub-object of another object, right? Which has, in this case, these gray object members. Now, A here could manage adding and removing objects from this collection, correct? And that's usually what people do. A linked list, for instance, manages adding its own things, but that's already at this level. But going one level further, where an object might have several different types of things and different collections, if we relied on the object A, to implement functions for adding and removing things from this collection, we will probably not make a mistake, but we could eliminate the possibility of making mistakes entirely by making restricting access to this object from the thing that contains it, A in this case. In my XML thing, I have all those nodes, okay, and the nodes have pointers to their children and so on. And I invented a list to keep track of the members in a different way, because I for some reason my algorithm for walking the list has a problem, and I didn't want to figure it out, so I just added a simple list for doing a global operation, like deleting them all. Now, these objects here are not really members of A. They're called nodes, and they're defined within A, in the case of that XML struct. But they are not actually members. A doesn't have A might have one of these objects as a member, but the whole collection is not. It wouldn't be a member. Each one wouldn't be a member of A. That is, it wouldn't be a piece of member data. This here M collection is a piece of member data. It's at a specific offset with respect to the struct, and that's what members are. These things are sort of independent. They're they're pointers to data, and they live in a chain. There's a chain, and one points to the next, and so on. Now, one thing you could do, as I said, is it's clear that we want this list to be the list of all these objects has to be a member of the outer object itself, right? It can't be independent of A. It can't be a global thing. It can't be a member of the node struct in any way, right? Let me show you the node thing. Where is that? XML. Okay, well, here's node. Maybe I should go into the history so you can see it more clearly prior to. Okay, well then use Notepad. I can't believe I assigned that. How do I change that association? What a dumb mistake that was. Options. View. Workflow. Different. Custom editor. Notepad. New file CPP. It wasn't what I was looking at, was it? Yeah, it would have been, yeah. So it was C. It was H. I don't know if that'll help. See this? There it is. Okay. Now this hasn't picked it up yet. Now this. Common H. This has, but this hasn't. Make it need to restart. So initially here I have this struct called a node inside of the class, and the nodes have their children and siblings and so on and so forth, and the whole thing turns into a tree by virtue of there being a single head node, and that from there you could navigate to any other node if you wanted. Now that's one way, and then I wanted to indent that list. So now underneath here, I added a list of node stars. Okay. Now the possible things that can go wrong with that. Let's see if it works now. Okay. Or let's say you want to add a new node comes along, and you want to create a new node. Where did I put it? Shouldn't be TSX here. New node comes along, and so this wouldn't be here. You would say new node and then list plus equals to new node, right? Unless you forget. And if you delete a node, you have to remember to delete it from the list. A much more solid way would be to let the node add itself to the list as soon as it comes into existence, right? Then you don't have to worry about adding, and when this thing dies, it can remove itself from that list, right? Now that would be perfectly solid, and there's no possibility of there being a mistake in adding or removing things from the list. However, that doesn't prevent this object from calling plus equals on that list. What I want that list to not have it. I want the list to be a member of this struct, but I don't want this struct to be able to call any of its members. So I was trying to think of a word for a kind of member that has that property, and I came up with well, not insular. What was the one I liked? Sequestered, I think. Sequestered. Oh, insular. Okay. I don't know. Maybe there is such a name for these types of things. These are members of a struct that are insulated from their parent. The parent does not have access to them. Some other kind of entity does, and auto manages the thing for the parent, so that the parent doesn't make any mistakes. So that's what I did in this case. Now the other thing too, which was was useful and in a sense needed, was that the nodes should know what their position is in that list. That is, the nodes maintain a position in the list of nodes. So that way, if you have a node star, right, you can find out where its position in the list is, and so if this thing dies, it can easily remove itself from the list, right? As well, I have some functions the idea of the way I've designed this thing is that I don't want to pass node stars back to the user. I just want to give them a p void of some sort, right? Now a useful p void could either be a node star, right? But it could also be a position in this list. That also gives you access to the node itself and the list. And so I have things a thing that will convert. Given this type of position, which is an unknown, but is in fact do I cast one? Anyone here? No. I can change it to anything I like, but currently, what I'm using for that p void, some position functions, is a member, is a position in the list, in the position of the global list. Okay, so that's what gets passed back, even though it wouldn't make no difference to the user. That's what gets passed back to them when they request a node in the tree. They get one of these things, and then in order to access the object, right? Suppose I want to get its firstborn. But this is a function that somebody would call. Give them a position. I say node star, the firstborn. I've got to convert now from this pause value to turn that into a node star, and that's quite easy because each these things are positions in that linked list, right? So all I've got to do is retrieve what's at position pause in the linked list, and that's fast. Similarly, if I have a node star and it maintains its own position in the list, I can go the other way around quickly. So these node things use the list and have full access to the list, but this class doesn't. And in the header file, you'll see the way that I've implemented that is instead of making that list just declaring a list like this, I made a new struct called a node list, which is a member of a node. Okay, so it's in the namespace of node, and it derives privately from this list. All right. And only exports a few functions, like get the count, head position, and getting at a position, different bits of data, but not adding or removing items, because that's where an asynchronization issue could come up. So there's no possibility of the outer struct adding something to that list and then causing there to be two things, identical things in the list. There's only one way for something to get added to that list, and that occurs in this constructor. You make a new node, and it immediately adds itself to the list, and that addition function returns the position in the list where that thing resides. Okay. So now that is being done to make sure that to reduce duplication issues, possibilities of error, like having two adds or not having a delete for an add, making absolutely certain that the add occurs and that it's the right number of adding. And I'm not removing the map destruction because I never take it. At present, I never remove anything, so I don't need that. It's only at the end when I delete everything. Okay, so the outer class has as a member a node list. Where is it? Here. Node list. And that's the list of all nodes. And it can use this function for walking through. And it can get the count, and it can get p nodes given a position value. Now, if I got rid of this list and went back to just using the node stars themselves, all I got to do is change this to the definition of position to stand for one of these, right? And implement the same function interface like this. Not hard, right? Get attributes, get path, data. Even easier. Were this a node star, all I gotta do is call the member. In fact, initially that's what they were. And I changed it, and nothing else had to change because this thing has no type information. So the implementation, it's like COM. Only the interface matters, right? And the outside world only sees this interface and doesn't need to worry about the details of what this thing is. Okay, so that's one lesson in not just protecting yourself from making mistakes, but in general, restricting access in an unusual way, and how that can be an advantage. In this case, I'm restricting a class from having access to one of its own members. And this has to be a member of this class. It can't be a member of anything else. This is the only possible place that it can be, right? In order for it to refer to what it refers to, the nodes that are maintained by this class. Again, that list couldn't be a member of this, right? This is this is the list, but it can't be a member of this because that's just one node. And a static member would be no good because that would be global to the universe, right? And we can have several of these things, so that's no good either. It has to be related to the object which the nodes are indirectly members of. I guess that's a little bit complicated, but in practice it works out fine. I have a program that uses that. It's a little unit test program. Okay, forget this tree stuff. I don't even want to think about it. I'll figure that out when I'm feeling ambitious. So here's just a little utility program which I can use. Given I pass a file name, and I might want to retrieve a sibling, and search for a node, maybe block its siblings, maybe get the attributes or data of a particular node, and maybe extract an icon or something. Not necessarily, from this data. It could be from a DLL or whatever. But this is a utility program to be used at the command line. What have I got for the thing here? Currently it says, so now that the switches first, I should put the actual file first. See the file. So the file is dev management msc.note, and I would like to look at this node, mmc console file, visual attributes icon, and I would like to extract the attributes section, and I would like the index attribute and the file attribute from that. Okay? Now, first I'll just run it like this. And here's what it came back with. The value of index is 4, and the value of file is this. Alright, let's have a look at that file. By the way, this might be funny to you. When I was first recording this, I ran into something of a conundrum. And eventually it dawned on me what the answer was. And maybe I should leave it as a puzzle. Let's see now, they're in docs, MSC. Dev management, this one. It was console. I'll see it faster. Something with icons. Visual attributes. Visual attributes icon. Right? There could be more than one, but it turns out there's only one icon section. Now what I could do is I could ask for image and then ask for the attribute, let's say name, right? And this bit, or just ask for the attribute's string and try to decipher it. And I can go from one image node to the next by using the flag I have here, sibling. Okay, this specifies, you specify a number, sibling 0, 1, 2, 3. The code's quite simple. It might look complicated, but it's not. Where's sibling? Here. So if the command line contains the node switch, first I find the position, the first node corresponding with the value in the switch. Now num repetitions depends on what the value of the sibling is that I've been given. So that might be 0, in which case we don't search further. But if the command line does contain the sibling switch, then I set the repetition value to that, to its number. I turn it to a number, and then loop around, repeatedly calling find first node from the last position, right? So that's how you can walk through the sibling nodes of a node. And now if this ends up being null, that means that you hit the end, right? This is just a utility program, so I'm not worried about it exiting here. Now as far as attributes, if there's an attribute switch, I get the attribute string. If it's empty, okay, that's an error. I'll copy the attributes from that position. What I'm doing here now is this stir copy attributes came from the command line. See, SW is switch, and I've designed this so that they're semicolon delimited strings, and no, that says /n. Oh no, but I know I'm adding a. No, these are semicolons. Yeah, that's correct. All right. Here I'm getting attributes from the XML file and putting carriage and making those carriage return delimited. Those are carriage return delimited, sorry. and I'm building a linked list of those, and then I'm comparing one list with the next. If I find a match, I return it. It's not that complicated. Now, here's the funny thing, though. Where was I? Was I in here? I was in this. I have another new project I'm looking at. This is completely just a thing that I want, and I'll add bits over time. All those TS string functions, right? I thought it would be useful if I had a utility where I could just call them from the command line. And I'm calling that utility string. And the flags would be what I want to do to a string argument, like rotate 13, right? Uppercase, ordinal just adds th or something, or capitalize or reverse, or do that base 64 thing, or get a substring, and so on and so forth, or tokenize. Well, anyway, one of the flags I had, and I'm going to put it back now, because I just realized as I was eating that I need it. And the flag was expand. To expand things if it's an environment variable, right? Now, here is the string that I was using, right? See if you can figure this out. I won't tell you the answer. I'll tell you next time. Here's the string that I'm using for my program, right? No, there's no expand here, correct? Compile this. This won't make any difference because there's no reference to expand anymore. Expand would have taken that %winder and turned it into C:/Windows, right? Well, that's the idea anyway. And I vaguely remembered, like in the back of my mind, do I handle that? Do I convert them in this command line thing? And I thought I did, because watch this. Look at that command line again. This happens in order. Whatever the string is, it happens to be this. At first it's going to reverse it, and then it's going to do a mid, like a substir, starting at position 4. Okay? So reverse the string, and then take substring starting at position 4. What do you think the output would be, given that I'm not expanding this? Well, I'll show you the output. Okay, now actually this also shows me the input. Reverse was specified, mid was specified with argument 4. The argument string was this. Okay? And then here it did its thing. It reversed it, and now I got string mid 4, that's starting at the 4th character, 4th position, 0 based. So reverse this, 0, 1, 2, 3, 4, starting at the end, right? Well, then I started running through this, and I put a breakpoint here, because that didn't make sense to me, because as I was stepping through this, I saw that %winder. I run up to here, and now I'm about to do the print, okay? Now, I have a list of things that I'm going to print out. Happens to have only one element. And here it is. Here's its one element. Okay? It didn't expand anything. So how is it that I got that funny output? And I can leave that as a puzzle. I'll give you a hint. And I've actually known this for ages. You see, when you run a program outside of the debugger, have you ever noticed that it stops? But when you run it from inside the debugger, it doesn't. It just it continues and it doesn't pause like the other way does. Okay, now remember that, and take any old program. How about U-test? Does that use the command? Well, doesn't matter. This program. Let's see now. I'm going to just remove that quotation mark there. And I'm going to run it. Control F5, like outside of the debugger. What? It didn't stop. That's your hint. Okay, see you. I forgot. I mean, I should have planned this better, but there's a comic element to these sequestered or isolated member variable things. I don't know if you noticed the comedy, and that is that the nodes, which are not even members of the class that contains the struct, right? They're declared in there. The node is declared here, but it's not a member of this, right? These nodes are actually contained in that container. These nodes can access that member variable. See? If this class called TSXML would like to have permission to access its own member, it has to acquire that permission from one of these node things that has access. These things have access to this data that isn't even a member of node, right? And of course, the way that works is that XML node is a friend of node list, okay? But XML is not a friend of node list. XML can't touch a node list, but one of these node things can. So that's why the constructor for node takes a pointer to an XML object, or it has to, in order to add itself to the list. It has to find out where the list is located, right? Now the list is located in an XML container passed in, and these objects have the right to modify the list. So that's why when you make a new node, when an XML file or whatever makes a new node, it has to pass this pointer in so that the node can use this pointer to locate the list within this object and add itself to the list. I thought that was kind of funny. Wait, there's one more thing maybe. Well, it has sort of to do with what I was doing with the virtual dev stuff, which you may or may not be following. But if you are, something of genuine worth came out of that whole exercise, I think. And maybe I'll just get to explaining that in the next virtual dev thing. But it's also, I think, a thing that can be applied to programming in general. And that is, we started out with a container, right? This wasn't the original. The original was gone by now. The original file was a bit ABI file, had a problem, and I wanted to go about fixing it. And the way to go about fixing that problem was I needed to convert the file into a format that I had tools which I could use in order to apply the repairs that I wanted to apply. Okay? And that one of those things is I had to take this super high quality AC3 audio stream and convert it to a lesser quality MP3 stream, because I can modify these things, but I have no idea how to modify these things. And then I wanted to glue these things together, and hopefully the MP3 stream would glue together nicely and not have any glitch. And it did. But as it turns out, it doesn't matter. Even if this thing did have a glitch, right? The act of everything that was done in order to make it possible to put that stream in, right, and get it working, at that point, I can throw away the old MP3 stream, and by a secret magic trick involving no encoding, replace that with the original highest quality stream, for which there cannot be a glitch in it because I don't even know how to edit it, and then there definitely will not be a glitch. If I wanted to get it back into MP3, I would then convert it again after having put it into its container and having chopped off the bits I don't want. Then I could convert it again, and there would definitely not be a glitch. So there never was a worry about there being a glitch in the MP3, in matching the MP3s. I was overly worried about that. I didn't realize that in doing what we did, we created a scenario which allowed me to replace, just by getting into a situation where you can handle the data, right? It doesn't matter if the data was a perfect match, because that scenario allowed for me to apply the other trick, to take some object that I have no idea how it works and overlay it on top of this other thing. And I think something like that could be done in programming where you don't know the exact layout of an object, but if you make an analogous scenario, like a simulation type thing, it might be a device, you make a simulator for the device, you get a thing working almost correctly, and then it should work correctly with the device that you don't understand, or nearly correctly anyway. Just a thought.